Okay, today we're gonna learn about the Spearman's rank coefficient, which is one of the coefficients for correlation. So we're gonna also use the concept of correlation to understand how the Spearman's rank is different than the Pearson's product moment correlation coefficient that we have studied before. So the learning outcomes are the following. Recognizing the difference between Pearson's and Spearman's correlation coefficients and when they are applied, and understand when, in which conditions each one of them are applicable, and if there are limitations. The format for this video lesson is part 1, the presentation of the topic with the theory behind, explanations, concepts, and examples. Part 2 is applying the concepts by solving further examples and or examination style questions. So let's present the topic. And we're going to have 4 contexts here. Think about the first context, which is a manufacturer decides to put a new product into the market. How can the manufacturers find out if this product is good, people will buy it, if there's going to be a success or not? Is it something that they do by chance? In context 2, just think about our lifestyles, and so we could think about our food preferences and see if there is a positive or negative correlation with the nutritional value of what we eat. Context 3, could we find a difference between two examinations, international examinations like the AP, Advanced Placement, and the IB? How do we do that? That's another type of test that we can apply. And finally, the fourth context is, can we find out about dice or coins, if they are biased, if they are not, how? So we actually apply a test to find out if they are biased or not, and not by just thinking, uh, by looking at the outcomes, if we should consider biased or not. We have to support our decision by using statistics. Okay, there are 4 types of data. The nominal data, they are separated into categories that don't have a particular order. So qualitative data, but not put in order. For example, a football team that people cheer for, Palmeiras, Corinthians, etc. There's no first, second, and third. On the other hand, the ordinal data, they have a first and second and third position, so they can put in ranks. That's the main difference between the nominal and ordinal data. The interval data has to do with the consistent distance between them. Most of the times we use time. So for example, every day or every month, what happens to the temperature as the month progresses. So month 1, month 2, month 3, and things like that. The ratio, we can relate the values proportionally to each other. So they're actually numbers. Numbers, they will find a ratio of proportion, something like that, which makes any tests that are related to ratio more precise. Let's take a look at the types of tests. We will be focusing today on Spearman's rank, and you will see this table in different videos. So we're going to focus here on the Spearman's rank correlation, which has to do with the ordinal data. So first, second, third. So the main thing is that we have to put in a rank. If we don't put in a rank, then we cannot use Spearman's. And also, if we use like numbers, I mean, they're not ranked, but they're actually data, numerical data. So then we're going to use the Pearson's product moments and not the Spearman. And this is because the Pearson's is more accurate, okay? So the more information I have, the more accurate my test will be. So let's revisit the Pearson's product moment correlation coefficient, or just R. Whenever we say R, is the Pearson's correlation, okay? So let me just change the color here. So we use the example of the highest temperature in degrees Celsius on a given day versus the rainfall in millimeters during the summer. We are assuming that it's rain season, so we expect to rain in most of the days. So what happens? We have the temperature, and for each day of the temperature, we have a rainfall. What do we do? Well, if you pause the video here, you can see all the steps. We get the statistics menu. Then we find out that we put on list one the values of the temperatures. On list two, we put the values of the rainfall. We plot a scatter graph. We calculate. We find out the R here. The R is here, 0.943. And here is also the linear regression for the line of best fits that we can see here on the diagram. For those who want to find out exactly how we do this, so we go to the menu. So we're going to go to statistics, right? After statistics, we see all the variables that they are there. So on list one, there are the temperatures. On list two, there are the rainfall. Okay, so we're gonna do a graph. Just take a look that on sets. Choose graph type scatter x. My x values are on list one. My y values on list two. Okay. Sorry, we have to exit first. Then we do graph one. We're gonna see the scatter graph here. And by pressing F1 again, we have the calculation of the linear regression. We want linear regression, so we're going to choose F2, which represents a linear value of x. And then we usually prefer AX plus B, which will give me here the correlation and also the coefficients of the line of best fits. And you can also draw to see how our data is actually close or a bit distant from the line of best fits. Okay. All right. So we found out that there is a correlation. That's the Pearson's again correlation coefficient, which is 0.943, saying that is a very strong positive correlation. For the examination purposes, if you put strong positive or very strong positive, there's no difference on that, okay? All right. So the Spearman's rank, we know that has to do with how strong the sets of the data are connected. But they use ranks instead of the pure data. So we'll have to change those values into data that are ranked. Okay, we're going to put like the first, the second, the third, so 1, 2, 3, and so on. We have to create another table with the data ranked from the first to the sixth. We usually create the rank from the highest to the lowest values, as first to last. And when two values are equal, we use the mean of their position. So we're going to see this in a different example. So let's put both of them and take a look. What is the highest temperature here? The highest temperature here, the number one, is 33. So we're going to put here number one. The second one is 30 degrees. So this becomes the second. And so on. The third is 29th. The fourth is 24th. And the fifth is 21. And the 19th is the 6th. So similarly, we're going to do this for the rainfall. And 13 is the number one, is the first data. So the highest value. The second one is 12, which is here. The third is 11, then 8, 7, and 5 are fourth, fifth, and sixth. So we put those values on the calculator. So you're going to see here the values 1, 2, 4, 6, etc. 1, 3, 4, 5. And we do exactly the same procedure, exactly the same. So the way of calculating the correlation coefficients that are Spearman's rank is exactly the same in the calculation. The difference is not how we calculate, but it's how the data is, okay, how the data is selected. And here we're gonna have, you should have on your calculator by doing this 0.833, which is here 0.8327. To three significant figures, 0.833, still very or just strong positive correlation. Let's do another example. So when two values are equal, we use the mean of their position. So let's do the same thing, but being careful with the values when they are equal. The highest value for x is 25. So this one must be number one, the first one. When we go to the second, both 23 are second and third. So what do we do? Because they are second and third, we're gonna get here the second plus the third divided by 2, which is the mean value of them, 2.5. So instead of putting 2 or 3, we're going to put here 2.5 and also here 2.5. Notice that we have used now the first, the second, the third data. So the next one, which is 21, must be the fourth. So it's 4. So we don't have 2 and 3. Instead of the second and the third, we have 2.5 in both of them. So then the fourth and the fifth is the 19 and the sixth is the 17. And similarly, I do with the y values. The highest one is 15. So that's the first one. The second one is 13. So that's the second one. When we get into the third and the fourth are both 12. So the third and the fourth positions are both 12. So what do? We find the mean. So for both of them, we're going to put 3.5 and 3.5. Remembering that we have the third and the fourth position. So the next one, which is 11, should be the fifth, then the sixth. Okay? Now, I invite you to pause the video and put those values into your calculator, and you're going to find out that the coefficient, correlation coefficient, which is the Spearman's correlation coefficient, is negative 0.851.